give one example for subnetting using class C. So in the previous video, we know what is meant by subnetting, what are all the types of subnetting that are we discussed in the previous video. And the types of subnetting are FLSM and VLSM. FLSM is fixed length subnet mask and VLSM is variable length subnet mask. So in fixed length subnet mask, for each and every subnet, the range of the address is equal. And in variable length subnet mask, the range of the address is different for each and every subnet based on the requirement. So here we can reduce the wastage of address space in VLSM. So normally we are using VLSM concept, but FLSM is the foundation for VLSM. So in this video, I am explaining about FLSM. It is comes under class full addressing. So for this is one example of class C type. So already we know for class C, the range of address it starts from 192 to 223. So here this address starts with 210. So it is comes under class C. So for class C, the subnet mask, default subnet mask is 24. That means network bit is 24 and host bit is 8. That is for class C type. But here we are using the subnetting concept. So the host bit 24, that is 8 bit is converted to 26 here. So total network bits now it is 26 and the remaining bits are host bit. For example, here by default first 3 bytes for network bits, so 24 bytes for network bit. Now 2 host bit is converted to network bit here, total 26 bits. So 26 bits are network bits now. Remaining 6 bits are considered as host bits here. Host bit is reduced, 8 bit is reduced to 6 bit now to avoid the wastage of address space. So the binary notation of the subnet mask is first 3 acted, it is 8. That means it is comes under the network bit. So all the binary notations of all the 8 bits, the first 3 acted is 1. 8 bit is 1. All the 8 bit is again 1 here. Again all the 8 bit is 1 here. But in the last acted, only 2 bits are converted to network bit. So first 2 bits are 1, the remaining 6 bits are 0 here. So this is converted network bits and the remaining 6 bits are host bit here. We can convert this binary notation into decimal dotted notation if all 8 bits are 1 means the decimal dotted notation decimal value is 255. Already these are all we know how to convert binary to decimal, that is 2 to the power 7 plus 2 to the power 6 plus 2 to the power 5 plus 2 to the power 4 plus 2 to the power 2 plus 2 to the power 1 plus 2 to the power 0. If we add all the 8 bits, we can get the decimal value as 255. If all 8 bits are 1, means it is 255. So in the first 3 acted, all the 8 bits are 1. So it is 255.255.255. But in the last acted, the converted network bit is only the first two position, 2 to the power 7 and 2 to the power 6. So 2 to the power 7 which is equal to 128 and 2 to the power 6 which is equal to 64. So 192. For the last acted, the decimal value is 192. This is the subnet mask for the value 26. Now we can find how many hosts are available. So total number of usable hosts. So 2 to the power h, we can find the h value now. We don't know about the h, but we know about n from the question. So here n plus h, total number of network bit and host bit is 32 by default. Here the n value is 26 from the question and 32 bit is the IPv4 address length. So h equal 32 minus 26, so 6 bits. Or else we can find it from the subnet mask itself. By default, the host bit is 8, but for class C, but here the first 2 bits, the leftmost 2 bits are converted to network bit. The remaining 6 bits only host bit here. From here also it is possible to write. Either we can use this formula n plus h equal 32, total network bits plus total host bit equal to 32, or from the binary notation itself easy to write. Network bit is given, from that we can find the host bit here. So 2 to the power h value is 6, 2 to the power h, for h now it is 6. Total 64 addresses are available in each and every subnet. So out of that 64 address, first address is used for network address and the last address is used for broadcast address. These network address and broadcast address are not assigned to any device in the network. So we consider the remaining 62 addresses are usable address. Here the -2 is nothing but the two addresses, first address and the last address. First address is the network address and the last address is the broadcast address. Remaining 62 addresses we can assign to any network here. So this is, in this way we have to find out the host here. And how many subnets are available in this network, small networks. So for that the formula is 2 to the power n. Here n is nothing but number of bits converted from host bit to network bit. So here itself we know the two bits are converted network bit. Actually this is host bit. These two bits are converted bit now. So n equal to 2, or else here the subnet value given in the question is 26. The subnet value given in the question is 26. By default C class, the subnet mask is 24. Remaining 2 bits is converted network bits. So this is one way to find the network bit, converted network bit. So 2 to the power n. Here n is not the total number of network bits. Converted network bit from host bit. So 2 to the power n equal 2 to the power 2, n equal to, so total 4 subnets are there. So subnet, you know, in the entire network is divided into smaller multiple networks. So here how many smaller networks are there means 4 subnets are there. So for each and every subnet, what is the range of the address that we know. So 2 to the power h equal to 6 already we know. 64 valid addresses are there in, not valid, 64 addresses are there in each and every subnet. So out of that 64, 2 addresses are used for network and broadcast, that and all we discussed in this previous, that is a valid host itself. So 64 addresses are there in the subnet. So for the 4 subnets, now we have to write the range of address. So for the first subnet, it starts with 210.10.10.0 because in the given question, the IP address, given IP address is 210.10.145. It is in between any one of the subnet. This IP address is available in any one of the subnet. So starting address for the first subnet, it is 0. We start it from 0 here, 210.10.0. So that is the first subnet network address. So how many addresses are available in each subnet? 64 addresses are available in each subnet. So 0 to 64. 64. Here we started from 0. 1 to 64 means here 1 to 64 we can write it directly. But here we start from 0. So here it ends with 63. 210.10.63. The subnet mask is given in the question. It is 26. This is the range of address for subnet 1. So for each and every subnet, 64 addresses are available. Total 4 subnets are there. So for subnet 1, subnet 2, subnet 3, subnet 4, we have to write the range of address. So it starts with the given IP address 210.210. Sorry, 210.10.10.0 for subnet 1, and the total address is 64. Here starts with 0, so here it ends with 64, or else you can add the 64 next to next year, then it is easy to write the broadcast address for the remaining subnets. For example, the first subnet it starts with 0 means the second subnet it starts with 64. You can add 64 with 0 here. For third subnet, the network address is 64 plus 64, it is 128. And for fourth subnet, 128 plus 64 is 193. So total 4 subnets are there in the network. So up to 4 we stop it. This is the network address for each and every subnet. So what is the broadcast address? Broadcast address, this is the network address for second network, means the previous address is the broadcast address for the subnet 1. So here it is 64, means the previous address is 63 here. Here for the third subnet, the network address is 128, means the broadcast address of subnet 2 is 127. And for fourth subnet, it is 193 network address, means for subnet 3, the broadcast address is 192. And for fourth subnet, suppose if you are adding 64 here, the value here is 256, but 256 is not possible because the range of the address is 0 to 255. So here the broadcast address is 255. So the total subnet for this problem is 4 subnet, and this is the network address for each subnet, and this is the broadcast address for each subnet, and the total address available between these subnet is 64, including network address and broadcast address. So the next address of the subnet is 210.10.10.1. Next one is 210.10.10.2. So similarly up to 63. So total 64 addresses are available in subnet 1. Similarly for subnet 2, 64, 210.10.64. Next address is 210.10.65. Next address is 210.10.66. Similarly up to 127. So again, if you are calculating the total number of address, here it is 64. So this is nothing but FLSM. For each and every subnet, 64 addresses are fixed here. So this is FLSM. Like already I told the example, for FLSM, it is their classrooms. In a school, all the classroom size are equal. Similarly here, for all the subnet, the size of the address is same here. So the network address, for in our given question, what is the question here? So given question is 1 210.10.10.145. So here 145 is available in the third net subnet, correct? 128 to 192. So 135 is available in this subnet. So for this given IP address, the network address is, first one is the network address. 210.10.128 is the network address, and 210.10.192 is the broadcast address. So this is one example for uh, FLSM in class C type. I will explain one more example in class C in the next video.